Now it is application time, aka word problems. And so this is really just to demonstrate that, yeah, these things actually are relevant and have bearing in our lives. When we talk about things growing or decaying, typically we're talking about an exponential model. And so you can see here there are a few different models, and then these two end up being equal to each other if we have this relationship that b from the first one is equal to e to the r. Loudness of a sound as measured in decibels behaves according to a logarithmic function. Magnitude of an earthquake is a logarithmic function measured using a Richter scale. And then pH, I'm sure you've encountered pH in chemistry, or if you haven't, you will soon. You compute that using a logarithm of the hydrogen ion concentration. Okay, so without further ado, let's go ahead and get started here. We're going to look at cesium-137. It says it's a radioactive metal with short half-life of that, and then we have a 2-gram sample, and then here's the function that it follows, the amount of time amount of the material in grams left at time t is given by that, and then we want to know how much will remain after each one of these. So this one might be a little bit more straightforward than the ones we will see later on. But all it's asking us to do is compute a of 30, right? A of 30 years. So then I would plug that in and do 2, and then 1/2 times, not 1/2 times, it'd be 1/2 with the exponent of 30 over 30, or 1. When you do it on a calculator, make sure to put that all in parentheses. Sometimes it'll divide it by 30 on accident, but if that's just 1, right, let's just ignore that. So then it's 2 times 1/2, which is 1. Similarly for 60 years, okay, it would be 2 times 1/2 to the power of 60 over 30, also known as 2 times 1/2 to the second, and 1/2 to the second is 1/4 times 2 is 1/2. So this is all in grams, and I should also say write sentences. Okay, for time purposes, I'm not going to. Okay, and for the last one, a of 100, you'd plug that in, and you end up getting about 0.2 grams. Okay, I rounded there. Okay, so that's just a nice little quick example of things following exponential growth or decay. Well, decay in this case. And now if we look at a hairdryer, it says it operates at 70 times the threshold of hearing. And then how many decibels does a hairdryer have while in use? Okay, well, we're talking about loudness, right? So that we're going to use the loudness formula. So we're just going to write that down. L of I is equal to 10 times log of I over IO. Okay, and so we notice that this is a function of I, so I need to know what I is. I would be the intensity of the sound for the hairdryer. 70 times the threshold of hearing. Writing this out mathematically literally means 70 times threshold of hearing is IO. That's what it's defined to be up here. Okay, you can also read more about it in the book. There's a specific number for the threshold of hearing. But so all I have to do here is substitute in 70 times IO. Okay, and so I get 10 times log of 70 IO over IO. Those end up canceling out. Again, they are actual numbers, something like 10 to the minus 12th. I think it's approximately 10 to the minus 12th, and then the units are watts per meter squared. So if you run across that, that's what it is. In any case, so we get 10 times log of 70, and then this logarithm is actually built into your computer calculator. So pause it for a minute and actually calculate this out. 10 times, and then hit the log button, 70. For most calculators, it would be like you would hit log and then type in 70 and then hit enter. Some of them you have to do 70 and then press log, so just make sure to play with your calculator to figure out what you get. What I got was about 18.5. 18.5 decibels. Okay. So those are just a couple quick examples of how we can use exponential functions and logarithmic functions in everyday applications.